Okay, let's start with the first question. October-November series, year 2017, paper 31, P3. The complex number u is given by u equals to 8 minus 59, showing all your necessary working. So whenever you are reading a question, make sure you underline or highlight the command words or key information in the question, which is over here, showing all your necessary working, which indicates means you are not supposed to use calculator in this question. You have to show each and every step so that examiner knows you know how to solve this kind of questions. Find the two square roots of u, means there would be two possible values which we have to mention. Give your answer in the form of a plus iota b, where a and b are real numbers and exact. Okay, so a and b are not imaginary. A plus iota b is an imaginary number, is a complex number, but a and b individually are real numbers. Okay, so once we have read the question, let's start with the solving part. So what they are saying is give your answer in the form of a plus iota b, which means that the square root of 8 minus 15i would be in the form of a plus iota b, where we don't know the value of a and b right now. So what I can say, we'll start with the standard way of solving this kind of questions. So what I can say is ki a plus iota b square should be equals to 8 minus 59, because if the square root of this number is a plus iota b, then the square of this number should be equals to this. Now this is the simple algebra formula, that is a plus b whole square, which can be written as a square plus I square b square plus 2 times abi equals to 8 minus 15i. Okay, so further over here I can simplify this. I can write down this as a square minus b square plus 2abi equals to 8 minus 15i. Now how to solve this is we will compare the real part. So this is my real part with the real part. On the left hand side we'll compare it on the right hand side, and the imaginary part on the left hand side has been compared from the right hand side. So we'll get two equations. One is a square minus b square equals to 8, and the second equation is 2 times of ab is equals to negative 15. So now we have two equations and two variables. So what we can do is, I'll start with this equation. I will substitute the value of b in this equation, and I will calculate the value of b from this equation. So I can write down b equals to negative 15 divided by 2a. Let's substitute this value over here. So we'll get a square negative 2 to 5 divided by 4a square equals to 8. Okay, so now next step what we can do is, I will multiply the whole equation by 4a square. So this can be written as 4a to the power 4 minus 2 to 5 equals to 32a square. Now taking all the values to one side, so we can write down this as 4a to the power 4 minus 32a square minus 2 to 5 equals to 0. Okay, now this seems to be a biquadratic equation, but it's, if you see it carefully, if you observe it carefully, it's a quadratic equation, but it's in the term of a square. The quadratic is in the term of a square. Now we know how to solve quadratic equations. There are different ways of solving. One is middle term splitting, means factorizing it. Second is we can use the direct formula, minus b plus minus root over b square minus 4ac upon 2a. Or what we can do is we can use the completing the square method. So I am going to use completing the square method in this case. So I can write down this as 2a square negative 8 whole square, which can be written as negative 64 negative 2 to 5 equals to 0. Now you will say how we got this negative 64, but if open this bracket, or expand this bracket, so you will see you will get one term which is 64, which was not there. And so what we did is we have subtracted 64 over here to make it balance equation. Okay, and we know how to solve any quadratic equation in completing the square method. Okay, so now the next step is I can write down this as 2a square minus 8 whole square equals to 289, which is further 2a square minus 8 is equals to square root of 289, which would be plus and minus. So I am solving this part over here. Now 2a square minus 8 equals to plus minus 70. Now 2a square equals to 8 plus minus 17. A square equals to 8 plus minus 17 by 2. Now we know a is a real number. It's already mentioned in the question that a is a real number. So we'll not have the negative value over here, because if we take negative 17, so 8 minus negative 17 will give us negative 9. So which is not possible value, because square number cannot be negative when they are real number. So we'll have possible value a square equals to 8 plus 17 divided by 2. So a equals to plus minus root over 25 by 2. So which further simplifies to plus minus 5 by square root of 2. Okay, now in this situation we have to simplify. Now we'll write down over here, if a equals to 5 by root 2, then the value of b using this equation, then the value of b would be negative 15 upon 2 5 by root 2. This is the value of b. Or if a equals to negative 5 by root 2, then the value would be negative 15 to negative 5 by root 2. So now if you simplify, you will get two possible values, which is, if you put this value over here, so we'll get two possible values. We can cancel this out. This root 2 cancels with this 2 will give us root 2. This 5 cancels with 3. So over here we'll get negative 3 divided by root 2. Over here we'll get positive 3 divided by root 2. So this is positive 3 divided by root 2. So now the possible square roots we will have is, I am writing it over here. Now the possible square roots we'll have is in the form of a plus iota b. So if I take 1 by root 2 common, so the possible value would be 5 minus 5 minus 3i, or 1 by root 2 negative 5 plus 3i. So these are the possible square roots of 8 minus 59. Okay, so now let's check the mark scheme, how we are supposed to get marks if we solve this question in exam. So what are the important steps we need to make sure? Okay, so first part is we start with this part and we solve this part. We write down this in this way and we'll get method marks 1 over here. Okay, now obtaining these expressions, this and this will give us accuracy mark over here A1. Now this part, eliminating or substituting one of the variable in the other equation and simplifying this part will give us method mark 1, and this part, if we form a correct equation, a quadratic equation after simplification, will give us accuracy mark over here. Then after solving this part, writing the two possible square roots, means this part, writing two possible square roots will give us another accuracy mark. So total 5 marks. Okay. Okay, now let's move on to the next question in the same paper. On the Argand diagram, shade the region whose points represent complex numbers satisfying both the inequalities. So first thing is this inequality, what does this inequality represents? So this inequality represents the equation of a locus of points in a circular form. Okay, so what I can do is I can write down this as mod z, and if I take negative common, so I'll get 2 plus I less than equals to 2, which means this represent locus of a point in circle whose center is this and the radius is 2. Okay, okay, let's draw this part. Okay, so what we'll do is let's draw some lines over here. So I'll draw this coordinate axis simply. Okay, now I'll draw this coordinate axis roughly. Okay, so now I'm going to mark the points roughly. Let's suppose this is my 1, 2, 3, 4, 5, 6. This is my REZ, means real axis of Z, real part of Z, and this is my IM Z. So I'm just marking it approximately. Okay, so from this equation we get to know what is our center. 2 plus I means first is we mark our center. So this center is 1, 2 plus I. So this is our center. This is the point of our center, and the radius is 2, means one part over here roughly, then 1, 2 over here. This is 1, 2 over here. So let's draw a rough circle over here with center this. This is rough. Okay, so let's suppose if I draw this part, we keep this part in the center. So this would be roughly our circle. Just trying to be accurate, not exactly accurate. Just relating this. Roughly 2 points, 2 points. Okay, so this is our roughly the circle which is touching, which would be touching this part. Okay, so now the next part is this argument. Argument means the angle theta. Now argument of z, when we say argument of z, which means the angle is from the real part of z, means this origin, at origin. Now argument of z minus 1 means our this line, the real part. Now the angle is from 1 point ahead, means this is shifted over here. So this is the line. Now argument of this is between 0 and pi by 4. Pi by 4 is around 45 degree, so which is approximately half in center. Okay, now this part is done. Now we have to shade the region which represents both the area. Now what does this represent? Means we have to find the group of points which are at equal distance or less distance from this particular point, which is less than 2, means all the inside point in the circle, means all the inside area for the circle. Now in this case the argument is more than 0 and less than pi by 4, which means this is more than 0, this is less than pi by 4. So which is the common region for both of this would be this area, this part, this region would be shaded. Okay, so in this case this is a 4 marks. So how we are supposed to get the marks for this question is, okay, first mark will get if we identify or if you mark the center correctly, means this point. If you mark this center correctly, so we'll get B1, which is independent mark. Now the second mark is to drawing a circle, proper circle with radius almost 2 and the center is not origin, will get B1 for the circle. Now showing the line, this line with proper line at 1 at imaginary part, which is 1, and the angle should be between 0 and pi by 4 roughly. So we'll get B1 marks for this part, and the last B1 for shading the correct region. Okay, so this way we'll get 4 out of 4 if we do this part over here, and in the first question we'll get 5 out of 5. Now the important thing over here is to know what exactly the examiners have want in the question and what the students have written or what the student has done in this question. So they have always go through the examiner report, so you'll get more idea exactly what kind of mistakes the people are doing and how we can avoid the same mistake. So these are the comment in the examiner report on a specific question, the same question. So some candidates made little progress as they tried to square root this. This is a legitimate approach, but it requires a polar form of complex number and it is extremely unlikely to lead. Means if you are working this directly, we start with the square root of 8 minus 59. This is correct, it's not wrong, but in this we'll need to work on our polar form of the complex number, which is extremely unlikely to lead to a exact answer. So what's the best method is, we start with this to obtain an exact answer requires the square root of u to be set up a plus iota b. So as we started, means to comparing, okay, the square of this would be equals to 8 minus 15i. Now then the thing is, reaching a quadratic equation in either a square or b square, you can eliminate any of the variable. Unfortunately, some candidates forgot to square root to find a and b, while others failed to simplify their answer, leaving root 25 and root 9 in it. Simplification of final answer will also be discussed. So what was the major thing? Most of the students started with this idea, which is correct, but it requires your understanding on polar form of complex number, which is extremely unlikely to lead to a exact answer because it's quite difficult in sense. But when you start with our standard approach, a plus iota b, square of this should be equals to 8 minus 59, then you will get a quadratic equation either in the terms of a square or b square, then you can solve it. Then some of the students were not able to simplify it, they have left it over here. So we have to make sure that we simplify and find out the correct answers. Okay, in the second, the circle was usually correct than the line, means most of the students were comfortable with the circle part, means, but line was difficult. Most of the student had circle of radius 2, but often the center was incorrect. So this is very important that we make the proper center, we mark the proper center. Then the line was often drawn from origin. This is the one big mistake I ask my students to avoid, that the line is often drawn from the center, because in the question it's not argument of z, it's argument of minus I, means this is a translation by 1 unit. So we need to make sure that we mark our angle correctly, means argument of that line correctly, even if both circles. Now the third point where they have made mistake is most of the student, even if both circle and line were correct, the candidates shading often extended over the circle below the line. Means what they have done is some of the candidate must have shaded this part also, this part also. So which is not the required region. Why this is not the required region? Because in this our argument is greater than equals to 0 and less than equals to pi by 4. So only this region, only this region, if you extend, only this region is included for this argument. And for the circle, this circle is less than equals to 2, means this is the maximum 2, less than means all the inside value. So only this portion we are supposed to shade. Okay, I hope you are clear with this idea and you are clear with the examiner report. So I hope you won't be making this kind of mistakes in your upcoming exam. Okay, okay, let's start with the second question. uh, Year 2017 October November series, syllabus P3 and paper 32. So the first thing we need to note over here is throughout this question use of calculator is not permitted. Okay, now the first question is the complex number 1 minus root 3i is denoted by u. Okay, find the modulus and the argument of u. Okay, fine. So over here what I will do is I will just roughly sketch this complex number on the argand plane. So this would be, let's suppose if this is 1, this is 2, this is 3, this is 1, 2, this is negative 1, this is negative 2. So this complex number is 1 comma negative 1.7. So this would be roughly somewhere over here. Now this is my z, or you can say u. So now if you see this height is root 3 and this distance is 1, and this angle is argument of this complex number. So at this point of time we'll use Pythagoras theorem to calculate the modulus of u. So I can write down modulus of u equals to root over 1 square plus negative root 3 square. So which is equals to 1 plus 3, which is equals to 2. So modulus of u is 2. So now we need to calculate the argument of u, and we know argument is the angle uh, inclination of the complex number. Okay, the angle theta. So now the angle theta is in the fourth quadrant and we know that the tangent of this would be negative. So we can write down argument of z is equals to negative of theta, so which is equals to negative tan inverse root 3 by 1, which is a standard angle, and we know the value of this angle, and this needs to be a standard angle because we are not supposed to use calculator over here. So I can say this is negative pi by 3 because this value represents tan 60 degree or pi by 3 radians. So argument of z is negative pi by 3 radians. Fine. Okay, now let's move on to the next part. Okay, now in second question we have to show that u cube plus 8 equals to 0, and we know the value of u is 1 minus root 3 I. So there are two ways to do this part. First is calculating the value of u cube, which we can use either the binomial expansion over here to find it out, but I am going to use this logic. I can write down u cube equals to u square into u, and I can write down 1 minus root 3i square into 1 minus root 3 I. So over here we can use simple algebraic formula over here, a minus b whole square, so which is a square minus 2 times of ab plus b square, so which is 3i square, multiplied by 1 minus root 3i. Okay, so now this part, this we know the value of I square equals to negative 1. So if we substitute this value, we'll get over here negative 3, and this is 1 over here. So negative 2 root 3 I multiplied by 1 minus root 3 I. By 1 this 2 terms, then we'll multiply by negative root 3i this 2 terms. So when we multiply it by 1, we'll get negative 2 root 3i, and when you multiply it by negative root 3i, so this will give you positive 2 root 3i, and this will give you again positive uh, root 3 into root 3 is 3, 3 into 2 is 6i square. So now if you see these two terms, we can cancel it out. Okay, sorry, this is I over here. So these two terms we can cancel it out. Now what we'll go to do is, we know again the value of I square is negative 1. So if you substitute I square equals to negative 1, so we'll get negative 6. Negative 6 and negative 2 is negative 8. So the value of u cube is negative 8. Now if you substitute the value of u cube in this equation, which we know u cube plus 8 equals to 0. So now if you say negative 8 plus 8 equals to 0, which is valid. Okay, 0 equals to 0. Or what we can do over here is, we can just start with LHS and we can say at the end LHS is equals to RHS. Left hand side is equals to right hand side. Okay, this part is done. Okay, now let's move on to the final part of this question. Okay, on a sketch of Argand diagram, shade the region whose points represents the complex number. So we have to sketch the Argand diagram and we have to shade the region whose complex number, whose points represent a complex number satisfying both the inequalities. This is one of the inequality, and second inequality is this, where RZ denotes the real part of Z. Okay, so for this part what I am going to do is, I'll just draw some kind of grid over here to start with. Okay, so now let's start drawing this part. First thing, we know u is equals to 1 minus root 3i. So z minus 1 minus root 3i less than equals to 2. So what does this complex number represent? What does this inequality represent is locus of point in a circle. So locus of point in a circle whose center is this 1 minus root 3i and radius is 2 units. So in this situation, first I will insert the axis over here roughly. This is the axis 1, and we'll have one more axis, that is horizontal axis. Okay, now what I'll do is, I'll just roughly mark. So I'll mark this point as 1. We know this is 1, 2, 3, 4. This is 1, 2, 3. Again this is 1, negative 1, negative 2. Similarly, and this is point 0. So center is 1 comma negative root 3i. So which would be, this is 1 and negative root 3 would be somewhere over here, roughly. This is our center roughly, and the radius of 2 units. So in this case I will draw a circle of 2 units. So diameter is 4 units. So now in this case, if this is the center, somewhere around here. Okay, so roughly this is our center. Now the second part in the question is that the real part, and we know this is the real axis for Z and this is the imaginary axis of Z, and real axis of Z is greater than equals to 2. So where is it 2? Over this part. So let's draw a line over here where it's 2. So we'll mark this using a line over here. and we're going to increase this part. Now the question is the real part of z. Now the first inequality is, that the complex number is, this represents less than area, means inside the circle area, and this represents that the real part of z is greater than 2. So only this line represents that the real part of z is equals to 2. So over here it will represent real part of z is greater than 2 over here. So we are going to shade this area. This represents the required region. Okay, now let's go through the mark scheme, how we are supposed to get mark over here. So in the first question, if we calculate the modulus correctly, we'll get here b1. Okay, and modulus you can also write plus minus. Okay, both of them are correct. Now if you calculate argument correctly, you'll get another b1, so you'll get total 2 marks. Okay, sure. Now in part of this over here, so if we solve this correctly, so you'll get 1 method mark over here, and if we show this part over here, so we'll get 1 accuracy mark over here. So now in this question, how we are going to get marks is, if we represent the circle correctly, you'll get 1 b1 over here. Now drawing the circle correctly with radius 2 units will give you another b1 marks. This line representing real part of z equals to 2 will give us another b1, and correctly shading the required area will give another b1. So 4 out of 4. Okay. Okay, so many candidates gave a full correct answer in the part 1. Most error were due to the argument of being stated as pi by 3. So error in modulus were due to arithmetic error or leaving the final answer as square root 4, which we should have written as 2 or plus minus 2. If your candidate does not appear to be aware of the terms used or the process required, so they had no idea how to deal with this kind of question, means few of them most probably. Okay, now in the second part, a minority of candidate use their answers from part 1, cubing the modulus. Very good, this is very good strategy, that the cubing the modulus and trebling the argument to give the concise and correct solution. The majority of candidates attempted to cube this part. Some of the candidates stated expansion of cube directly often reach out to the correct answer. Candidate who started by squaring the number usually did better if they simplified this to this before proceeding, which we have done in our solution part. Most common algebraical error was this, that a minus b whole cube is a cube minus b cube, which is 100% wrong. Some of the candidates simply ignored the I and found the cube of this, which is also wrong, because we need to find out z cube, u cube, sorry, in this question, and u is 1 minus root 3i, not 1 minus root 3. Okay, in the final question, most of the candidates offered an attempt to draw the Arkan diagram. Several fully correct diagrams were seen. Majority of the diagrams did use the same scale. This is very important, that we should use the same scale on real and imaginary axis. Most diagram include a circle, usually in correct quadrant, but often not passing to the origin. So which is important? Some circles were centered as this, which is wrongly interpreted as the center, and some on this. So the straight line was sometimes horizontal or sometimes diagonal passing through origin. Some candidates drew 2 circles. So done with this. Now let's move on to the next question. Okay, the question in paper code 33 is exactly same which has been asked in paper code 31. So we are not going to solve it again. You can just go through this question again. It's the same. So if you have seen the solution of 31, there is no need of doing it again for the sake of doing this question. So by this we have solved all the questions asked in year 2017 October November on the topic complex numbers. I hope you all enjoyed this video. Thank you very much.